Hello, grade 11s. The other day we started talking about how to determine if data that we are provided is normally distributed. Now, the first thing we said was we can kind of sort of tell if data is normally distributed if we graph it using a histogram. Okay? Now, the reason why I say kind of sort of is because if that data very clearly represents a normal distribution curve, then we can quite confidently say that for sure it's normally distributed. If that data in no means represents a normal distribution curve, then of course we can say it's not normally distributed. But there is some gray area because how close does it have to be close enough? And that's really hard to tell. So we're going to take a look at this example. So we had student shoe sizes of 15-year-olds, as well as the number of students that wore each shoe size. We started creating this histogram, but we didn't quite finish. So I'm going to go ahead and do that with you now. So under the shoe size of 5, there was 49 students. And that rectangular bar that I'm making should be just under that 50 point. And so that it's clear, I'm also going to label it 49. I'm going to do that for every single value. So for 6, there was 94. So 90 is around there. So 94 is just between the 90 and the 100 and just under the halfway point. Something to keep in mind is I know that 94 is less than halfway, but pretty close. So if I have these grid lines here, I should be representing that information accurately. So if I drew that 94 mark way up here, that would be incorrect. Okay? For the shoe size of 7, there's 118, which is really close to 120, but still underneath. And I'm going to label that 118. Now, those data values on top are useful, especially if I can't clearly read the value from the side. All right, the next one, 92, so just over 90, in and around there. Beautiful. After that, we have 60. So 60, we'll take a peek in around here. This one actually falls directly on the line, so that's very convenient. Then we've got 65, so halfway between 60 and 70. And, of course, we end up with 40. And this is what I've got. So this is my beautiful histogram, and hopefully your histogram looks just as beautiful. Title, axes, labels, clearly accurate in terms of heights. The scale is consistent. We've got a lot of really good things going for it. Now, if I take a look at this overall shape, I can see some similarities to a normally distributed curve, right? I can see kind of this vibe going on. However, it's definitely not perfect, right? I don't have full symmetry, right? Because if I'm looking there, there's definitely way more data values towards the larger shoe sizes as there are the smaller as there is to like the middle, right? Or where that peak is. So I'm not 100% sure, and because of that, it's often really hard to tell that data is normally distributed by doing that graphically. All we can say is that it's likely to be normally distributed or unlikely to be normally distributed. So in a situation like this, I would say it's quite possibly normally distributed based on the shape, but I can't tell for sure. So, graphically isn't the best solution. What is the best solution is algebraically. And before we kind of talk about how that algebraic process looks, let's remind ourselves of the 68, 95, and 99.7% rule. Now, in a normally distributed curve, I know that the mean should exist pretty much in the middle. And that mean can be represented with an x-bar, which we use most often, or this mu here. Now, when I take a look and I add one standard deviation, so I have my mean and I've added one standard deviation, I get this marking here. And when I do the same thing, take my mean, except now this time subtract one standard deviation, I get this marking over here. Now, based on my 68, 95, 99.7% rule, I know that this information, this data that falls between one standard deviation of the mean, should be about 68% of the data. And that is what we're going to look at when trying to algebraically prove if our data is normally distributed or not. We are going to physically calculate the percent of data that falls within one standard deviation of the mean. And then we're going to see if it matches 68%. If it does, fantastic. If it doesn't, then it's not normally distributed. So that's going to be our strat. Okay? So let's get rid of this and take a look at the same set of data. Now, what I'd like you to do is start by plugging in this data into your calculator, calculate the mean, and calculate the standard deviation. Go. Hopefully you paused the video. If you didn't, pause the video now. Okay. And when you did that, you should get, when you round to 2 decimal places, a mean of 7.72, and that's the shoe size, and a standard deviation of 1.74, again, in terms of your shoe size. Now, shoe sizes don't really have units, so I'm not writing down the units here, but if they did, I would. If you're like not sure in a situation, you could always write down shoe size, even though that's not technically a unit, it's what I'm measuring, if it makes you feel better. Now that we have that information, we should be able to find the two boundaries, the lowest value and the highest value, in which 68% of data falls between. Now, I know that those two boundary lines are my mean minus my one standard deviation and my mean plus one standard deviation. So 7.72 minus 1.74 gives me 5.98. And I'm going to do the same thing, except I'm adding now. Same number, 7.72. Now I'm adding one standard deviation, and I get 9.46. Now remember, these are the data values, the boundary lines, that we are trying to see how much data falls between them. And ideally, 68%. Okay? Now we have to actually calculate how much data falls between them. So the first thing that we're going to do is we're going to identify which data values fall within that range. So I'm going to write data values in between 5.98 and 9.46. And these are my data values, right? This first column is my data value, set of data values. Which of those numbers fall in between 5.98 and 9.46? Well, 5 does not. It's too small. 6 does. 7 does. 8 does. 9 does. 10 does not. It is larger than that. So I am looking for data values that are 6, 7, 8, and 9. But it's not just the data values I want. I want to know how many data values fall within that range. So how I do that is I take a look at their frequencies, the number of times that they occur, and I add them together. So the total number of data values within that one standard deviation is the sum of all of their frequencies. So I'm adding 94, I'm adding 118, I'm adding 92, and I'm adding 60. Because that's how many people, how many students have a shoe size that is either a size 6, a size 7, a size 8, or a size 9. And when I get that and do that addition, I get 364. Now that value is going to be handy later on. That's the value I'm trying to find. Next, I need to figure out the percent of data that falls within one standard deviation. Now, this number that we just calculated is the numerator. It's the number of data values within that one standard deviation. How many students physically had a shoe size that was in between 5.98 and 9.46? That's my numerator. My denominator is the total number of students that were involved at all. So my total number of data values, not just within the range, but grand total. And that's found by adding every single frequency value together. So not just those 4 within range, but all of them. So to find that denominator, I'm going to add those things together, all of the frequencies. When you add those frequencies together, we should get a number that's 518. Now, this fraction kind of acts like in the same way as a mark on your test, right? The top is what you've earned, the bottom is the total that you could have gotten. Same idea when I'm talking about the frequencies. The top is what's within my range, the bottom is the total number. And just like finding percentages on your test, you divide the fraction and then you have to multiply by 100%. And then we get a number. And in this case, the number ends up being, when rounded to 2 decimals, 70.27%. Okay, now here's the golden rule. I realize that what should be the true answer is 68%. But quite honestly, 70 is really close to that. How close will we accept for it to be considered normally distributed? Well, if whatever answer I get is up to a maximum of 4 away in either direction from 68%, so either 4 smaller or 4 larger, so either 64% to 72%, if it is within that range, I can claim that my data is normally distributed. If the percentage I get is not within 4% of 68, then I would say, no, my data is not normally distributed. And because we actually have quantifiable numbers that we have like that firm threshold of yes, it is or no, it isn't, it's a lot easier to use than that graphical method, because the graphical method gives you a little bit of gray area and we don't know how to act in every situation. Algebraically, we do. So we do need to have that final statement. So I would say 70.27% of data falls within one standard deviation of the mean. Therefore, the 3 dots, the data is normally distributed. Okay. So when I take a look at the algebraic piece, obviously my data is going to change every time. My numbers are going to change every time. I'm going to get slightly different calculations, but I do have 5 steps. Okay, and just to reiterate, step 1, I'm calculating that mean and that standard deviation. I'm using that, hitting that stat button, I'm sliding over to calculate. I'm hitting one var stats, L1 and L2, and I'm calculating that to get these values. My next step is I am figuring out that threshold in which, or that range in which 68% of the data should fall between. So 1 standard deviation down and 1 standard deviation up. Next, I am calculating how many, or I guess counting really, how many data values fall within that range. After that, I am using that answer as well as the grand total to figure out my percentage. And last but not least, I'm making a conclusion. I need to have those 5 steps to algebraically show that something is normally distributed. Okay, that is it. That is all. There's practice that follows. Please work on that. Next time we see each other, we are going to discuss a quiz date for 5.4 and 5.5. All right. Have a lovely rest of your day, and I will see you soon. Bye.